Okay, I've taken the lower valve body now and have bolted it up to the holding fixture. I used 3 1-inch long bolts in this location and here and here. And I've adjusted my table so I can mount it to it. And I'm going to do a slight change up. Instead of doing the channel cuts first, I'm going to do the plunge cut for the aluminum block off pin in this location right here. All right, let me raise it up so we can see it a little better. And where I want to make the cut is right on the diagonal here at a 45-degree angle from the channel. And I want to go in a 1/2 inch deep, not more than a 1/2 inch, it might come out the other side. And the challenge to make this cut is that the floor of the channel is slightly tapered. So as I make the plunge, the burr bit may want to ride off to one side. So I'll have to be very careful and very methodical and slow as I make this cut. All right, let's take a look. Looks good to me. Okay, I've removed the lower valve body from the holding fixture and I've brought out my prototype valve body because I want to show you a little comparison. The next cut we want to make is the relief cut for the transbrake release valve. So let me drop it down in the valve body and let's take a closer look. What I want to do is to countersink this bore so the edge of the valve body lines up with the outer edge of this land right here, and I can illustrate that on this other valve body. Okay, see how the countersink or that chamfer lines up perfectly with the outer edge of the valve right here. Okay, so what I'll do, I'll take the valve body that we're working on, go over to my drill press, and I'm going to start drilling very carefully, just a little bit at a time. Then take the valve, put it in there, check the fit. I'll have to blow the filings out with compressed air each time. And once I get it right in the right place, normally the countersinking bit will leave kind of a serrated edge. So then I'll take that tapered stone that I have and dress it up just a little bit to smooth it up. I think that's perfect. Let me put the stone in there and clean it up. Okay, now I want to tap a couple holes. I want to take a 10 by 32 tap and go down in this hole right here. And I want to take a 1/4 inch pipe tap and go into this hole. You might use a little bit of transmission fluid to help make the cut, and also be sure that you go in nice and straight. Okay, now it's time for the pipe tap. And by the way, you don't need to pre-drill any of these holes. They're the right size to begin with. If you happen to have a socket with one of those T-handles, that would really come in handy here because, again, you want to go in nice and straight when you make this tap. Okay, I think that's far enough. Let me pull it out and clean everything up. Okay, I'll put the set screw in first. I need to put a drop of red Loctite on it, run it down in there. And by the way, when you tap that hole, you don't want to tap it all the way through, because if the set screw goes in too deep, it'll actually interfere with the manual valve. So once you put this in, I would put the manual valve through there and make sure there's no interference. There we go. No problem. Now let me put the pipe plug in. Okay, I'll put a drop of red Loctite on it. Run this plug down flush. If it goes a little past flush, that's fine. And if it sticks out of the hole just a little bit, take a die grinder and smooth it out flush with the end of the valve body. Now I want to tap in that aluminum pin. Okay, and I chamfered this pin just like I did the other two, and if you run out of these pins, that's no problem, because 1/4 inch aluminum rod can be bought pretty much at any hardware store. Alright, I'll epoxy this in place and then let both halves of the valve body cure overnight, and then we'll make the final cuts. Okay, all of the epoxy has cured now. I've taken the upper valve body and bolted it back to my holding fixture. I think I called this lower valve body a couple times in a previous scene. Just remember, the upper valve body here is the one that has the manual valve and the brake valve. The lower valve body is the one that has the pressure regulator and the screen is bolted to it. All right, let me drop it on my table, and now let's take a closer look at what's left to be done. Now off camera I made 3 plunge cuts in the yellow area that's to be cut to make it a little bit easier to make this last modification. Okay, this cut right here is the one that I'm the most concerned about. What I want to do is try not to cut into this, let's call it the plateau area, very much. I'm going to take most of the material off of this side. Let's take a look at the prototype valve body and see how that cut came out. If you look here in this plateau area, you see that there's almost no cut at all. All of the cut was biased to the other side. Yet, there's still plenty of material here to keep from having a cross bleed into this slot. And you also notice that this pin, the block-off pin, is mounted a little bit lower. It's closer to this cavity, giving me plenty room to make the cut in this area here. On our project valve body, the pin is mounted a little bit higher. I think that's going to cause a little bit of a concern, but I think with a little finesse I can still make the cut, keep the cut from being too close to this slot, and if I have to, I'll even cut into the pin just a little bit. I think the epoxy that's already there is going to keep it liquid tight. If I have to, I may add just a little bit more epoxy after the cut is made if it's warranted. Okay, for the final cuts on the upper valve body, we can use the 1/4 inch burr bit that has the little dome on it, or we can use the bit that's already in the router, the one that has the 1/4 inch ball. Okay, just remember the cut depth of this area right here will be a 1/2 inch deep. Next to it, by the block-off pin, we want to go 5/16 in depth, just like all of the cuts that were made on the lower valve body. Back here, we only want to go 1/4 inch deep. And over here, we want to make another 5/16 depth cut, but only 1/4 inch wide. Okay, let me make this controversial cut first here. Get this one out of the way. Okay, I think that's it, and using the 1/4 inch ball burr bit, I believe, was the way to go on this cut. Okay, let's finish the rest of the cuts, and remember, 1/16 of an inch depth at a time. All right, I think that's it. Now let's take a closer look at the work. Okay, 1/2 inch depth there, 1/4 inch depth there, and of course 5/16 here and here. All right, let me remove the valve body, and there's some final machine work to be done. Okay, I've blown everything off again and the dirty work is almost done, but I still need to take the 2 aluminum pins that are on the lower valve body and the 1 pin that's on the upper valve body and cut those down smooth with the surrounding area. Now I've already started on it. I'm taking my coarse file that I have, and what I want to do is just keep working on the top of those aluminum pins until I just start to shine up the surrounding area. Then I'll put the final touch using this medium coarse file, which is actually a little bit larger, and put the final few strokes on it. That looks pretty good. And go to the other file. I think that's it. Let me do the other one. I believe that'll do it. Okay, I've blown everything off again, and there's a little bit of dirty work left to do, and that's deburring. And a lot of times that's overlooked, but it's very important. When you're using these carbide burrs and you make these cuts in the passages, little pieces of metal can stick off the edge, and later on those little pieces could fall off, get through the system, get up inside a pressure regulator, cause it to stick, and then you have pressure problems. So you need to do some deburring. Now you can take and put a stone, a little teeny stone on, the die grinder, or you can just simply get one of these little kits I got in the hardware store that has real small files. This is a real small flat file. Here is a round one with a point on the end. I think it's only about 1/16 of an inch in diameter. And you can go down in the area where you made those cuts and use the file kind of like a strop. Just kind of go across the edge, and that'll knock off those little jagged edges, those little burrs that are sticking up. Then blow everything off, clean everything up with brake clean, go down through the bores with one of these rifle brushes, get it all nice and clean, and then you'll be ready for final assembly. Okay, before we actually reassemble this valve body, I want to go through a general explanation on why we're doing this. Why did we cut those passages? Why did we block off some passages? I want to take some of the mystery out of what a transbrake valve body actually does. Okay, to illustrate this exercise, I have the upper and the lower valve bodies laid out in mirror images of each other. So in other words, when I put the separator plate on the upper valve body and I'm following a flow path from it through a hole in the separator plate, it's a matter of flipping the separator plate over 180 degrees, and then I find out where the flow winds up going in the lower valve body. Now understand, I'm not going to explain what every single one of these passageways does or where it goes. Frankly, I don't know that anyway, and the video would be 6 hours long. It's more important to understand that once you start the engine and pressure builds up in the pressure regulator area right here in the lower valve body, that line pressure in turn goes through one of the holes in the separator plate and then emerges in the upper valve body in this kind of funny S-shaped passage here, which is over top of the manual valve. So depending on the orientation of the manual valve, that line pressure winds up going into another passageway which goes to a clutch or a band, or in some way interacts with the function of the transbrake. So we'll start with this S passage right here and then follow the fluid flow in each one of the shift ranges. Okay, understand when the engine is running and you're in either park or neutral, fluid pressure is pretty much isolated to this S passage. And that's because the orientation of the manual valve allows pressure only to be in this valley area right here, which means all of these slots up this way and the slots down here are blocked off to the pressure, therefore not being able to go to any of the clutches or the band. Okay, now let's see what happens when I put the manual valve in the first gear position. What happens is the manual valve is oriented so this land area now opens this passage, the S passage, up to this cavity, this one here, which goes over here, and to this passageway here that winds up going to the block-off pin in this location. This line pressure now goes into this passage, and let's follow it. Goes down across the valve body, runs down into this position, and remember, this is where the high-speed downshift timing valve used to be, but in this modification the valve is done away with. Therefore, the fluid jumps into this passage and follows down and winds up right here. Okay, if we take a look at the separator plate, we'll see that there's a hole in that location. Let's transfer it over to the lower valve body. Pressure goes down in that hole, which winds up in this cavity here, which has a hole in the side. And that hole is where the servo tube engages. So therefore the pressure goes down the tube and of course goes into the apply side of the servo, giving you first gear. Okay, back over on the upper valve body, remember I said that now fluid pressure is being introduced into this cavity here where the block-off pin is, and in this slot right here. But because the brake valve is in the off position, in the exhausted position, we can see that the rear brake land is crossing over top of that slot. That's keeping fluid pressure from going any further than this valve. However, when you push in on the solenoid button, remember the solenoid would normally be off like this, and you push in the button, now the solenoid is energized, pops out, this area here is now pushing on the valve. So the valve now goes into the valve body and that exhaust area is now blocked off. At the very same time, the land that was crossing that slot is now moved back and you have the valley area of the valve. So now the fluid pressure goes from this slot into this cavity right here. And from that cavity it goes to the lower valve body. So let's follow it. We take the separator plate and the fluid goes from this slot. Remember, it's not escaping out of the valve because that's blocked off now. So let's go over to the lower valve body. All right, and we see the pressure goes down in this hole, which in turn goes into this real large chamber that we opened up earlier in the build. Again, if we had a single dump trans brake, it would only go into this passage here, but in our case we're running a double dump trans brake, so this passage is open also. Let's put the separator plate back on. Again, on a single dump, this would be blocked off, only this hole would be open. In our case, both of these are open. These holes then in turn go into the case in this location, again on a single dump, or both of these locations in a double dump. And of course, that fluid goes down into the reverse clutch, which engages the reverse clutch, and because the band is also on, you're in first gear and in reverse at the same time, which essentially locks up the output shaft and your brake is applied. Back here at the upper valve body, the car is staged, the engine's revved up, and you're ready to release the trans brake. Okay, what happens? All right, the solenoid would be in the normal in position, and when you release the button, or after the delay, if you have a delay box, the solenoid would suddenly pop out, or it's actually being forced out by the brake valve itself. And the reason the valve pushes out is because of the laws of hydraulics. You have hydraulic pressure in this valley area here, and it's acting on the smaller land area in this location and the larger land area on the front. The law of hydraulics dictate that the land that has the larger area would have the greater force exerted on it. Therefore, hydraulically, the valve will be pushed right on out. And when that happens, of course, now that escape area, or that release area, now is open to atmosphere, and all that pressure that was built up here going back to the reverse clutch suddenly escapes out past this valve. At the same time, the rear land area has now closed off this passageway, keeping fluid from being reintroduced into this large cavity. Okay, now let's see what happens when you shift into high gear. I'll move the manual valve to the high gear position. Hydraulic pressure is still coming from this S cavity over into this same passage as it was before, which energizes the low band, but it also allows this slot to be open. We'll take the manual valve and put it in that position, and now you see the valley area is between here and this slot. So let's take a look at the separator plate, and we see fluid will come out of this passage right here. Let's transfer it to the lower valve body. And fluid goes down in this hole right here, which is actually this slot. And because the shift valve valley is permanently positioned because of the spring that's going to go on the end of the valve, this valley area opens this passage and this passage here, which goes down over to this slot right here. Then when we look at the separator plate, we see it's that passage. All right, now let's see where that goes on the upper valve body. Goes down right there, which is this cavity right here, and that follows down all the way to this position back here. If we take a look at the separator plate, we see it's this hole. Now let's see where that goes on the lower valve body. Pressure goes down in that hole, goes into this cavity, snakes around to the top, then comes out of this hole in the separator plate, which in turn goes into the hole in the case, which is the apply passage for the direct clutch. It's also the release side of the low gear band. Therefore, releasing the band, clutch coming on, and you have high gear. Back over at the upper valve body, I want to tell you about a little quirk on this system. That is, when you're in high gear, because of the position of the lands of the manual valve, this passageway now no longer has pressure on it. Therefore, when you're in high gear, if you even accidentally engage the brake, nothing would happen because there is no pressure here to add fluid to this cavity. Therefore, it creates somewhat of a fail-safe. You're in high gear, you can't accidentally engage the transbrake. All right, now let's look at one more position, and that's reverse. When I put the manual valve in the reverse position, now this hydraulic pressure is blocked from going in this direction. Therefore, it cannot get to this passageway, which is needed to be able to go to the transbrake valve. Instead, the fluid pressure can go in the opposite direction, and it actually comes out of this slot that has a kind of a shape like a boot. So let's take the separator plate and see where it comes out. Well, it comes out this passage here. Let's transfer it to the lower valve body and see where it terminates. Goes down in that hole, which comes right at one of the new passages that we cut. Follows this pathway here to another new cut that we made and comes out right here near the shift valve. Comes out this hole. Now let's see where it transfers over to the upper valve body. Pressure goes down that hole, which in turn goes into that slot right there. And with the manual valve in the reverse position, there's a valley there allowing that pressure to go from that slot to go into this channel, which in turn pressurizes this area up here where the brake valve is. So to give you reverse, you have to have the manual valve in the reverse position, plus you have to push on the transbrake button, which energizes the solenoid, pushing in the brake valve, allowing the pressure to go from this channel into this large channel here, which of course pressurizes the reverse clutch, giving you reverse. And that was kind of a complicated way to get reverse, wasn't it? But it had to be built that way. And hopefully this gave you a little bit better understanding on what goes on in a Powerglide transbrake valve body. Okay, let's first start by putting the shift valve back into the lower valve body. Just to make it a little bit easier to see in the video, I'm going to put these little short studs in the valve body and lay it down in my clamping bench. Now only the outer sleeve, the little valve that goes on the inside of that, the shift valve itself, and the little spring that came in the kit will be installed in the bore. The two springs that were originally in the shift valve will be eliminated. I'll drop in the spring from the kit, and I may need a screwdriver to kind of help it get down through the bore so it's all the way at the bottom. Then I'll take the shift valve, drop that in, and sometimes it's a little bit troublesome to get it down through the bore, so I may use some needle nose pliers here just to get it positioned. Push it all the way down, as far down as I can get it. Then I'll take this Carter key and stick it in there to keep it from coming back up too far. Then I'll take the sleeve, and I've already put a little bit of Vaseline down in the cavity of the sleeve, so I can put this valve in there, and the Vaseline will kind of glue it in place, so as I drop it down in the bore, it won't slide out on me. Now I'll put the snap ring in. I'll just put some thumb pressure on the sleeve, push it down against that spring, and it looks like I got it in. Pull the Carter key out, and now let's put the pressure regulator in. Okay, if you have trouble getting the snap ring on, all you need to do is grind off just a little bit of the tip of this valve. That will allow that sleeve to go in just a little bit deeper, and you'll be able to get that snap ring on. And flip it around, and we'll drop the pressure regulator in first. And it needs to fall down by its own weight. I'm going to take this magnet, make sure it's nice and loose. No problem at all. That's what I want. If that didn't drop down by its own weight, clean it out again, check to see if there's any burrs in there, make sure that it definitely drops in there by its own weight. Next, the new pressure regulator spring that came in the kit. This is a lot stronger spring. This will cause the line pressure to be higher. Get that down in there. Then put the little washer, you know, it has a little lip on it. The lip side goes down to the spring. Then I'll put that little valve inside the sleeve. I've already put some Vaseline in there to kind of lube it up and glue it, so when I flip it over it won't fall out. And then I have to compress this with my thumb, and believe me, it takes a lot of thumb pressure to get that compressed. Let me get my snap ring lined up. Push with my thumb and get that snap ring in position. And be sure you have your safety glasses on, because this could pop out of its groove, hit you in the face. Looks like I got it. Okay, now let's bring the upper valve body to the table and the separator plate, or transfer plate, I believe it's called in the instructions. And what we'll do, we'll set the transfer plate on the upper valve body, then flip the lower valve body onto it, line up the holes, and start putting the bolts in. Remember, there's 15 of these bolts. All you want to do now is just stick them in 2 or 3 threads. And remember, the bolt with the little tab on it goes in this location. Okay, now I want to flip it over. Okay, before we torque up the 15 bolts, I want to make sure that the separator plate is lined up perfectly with that lower valve body. And I found that 2 of the bolt holes in the separator plate are slightly smaller in diameter. And that's this one and this one. So if I take 2 of the valve body to case bolts and drop them down in that hole, the shoulder of the bolt will fit snugly in those 2 holes, therefore lining up that separator plate perfectly. So I'll put nuts on the back side just to keep the bolts from sliding out. Flipping it over, and now I'll torque the 15 bolts. Now the torque spec is 15 foot-pounds. If you happen to have an inch-pound torque wrench, 150 to 180 inch-pounds will do the job as well. If you don't have any torque wrench at all, I believe if you use a socket on a short ratchet and use one hand, that will keep you from over-torquing it. And you should be able to tighten it fine that way. Remember the tab orientation on this bolt. And put the final torque on it, and actually that one-handed trick with the ratchet was pretty close. Pretty close. Alright, I'll take my alignment bolts out. Put the manual valve in. Install the servo tube. And drop the valve body down in the case. Okay, with the valve body bolted to the case, be sure your servo tube is engaged correctly in the servo housing over here. Make sure that your manual valve is engaged in your shift linkage here, and your spring is mounted on your detent lever. Now understand, you have 4 bolts at the bottom, you have 3 bolts at the top that attach the valve body to the case, you have 1 short bolt here, and the other long bolt also holds down the guide plate. And of course there's another smaller screw on this side, and all of these bolts have a torque of 15 foot-pounds. If you don't have a torque wrench, I believe if you use one hand with a short ratchet, you'll be fine. Okay, before we leave the valve body, I want to talk about one more item, and that is the installation of the brake valve. Now you just put it right through the old modulator hole, and you should put a little bit of transmission fluid on the valve along with the other valves in the valve body. Make sure that that valve moves nice and free in the valve body, and then take your brake solenoid and thread it into the case. Now the instructions give no reference to any kind of clearance or adjustment, but I wanted to know what the relationship of that valve to the solenoid is. So I found that with the solenoid in finger tight, and I push in on the disc, there's a slight gap between the disc and the body. I measured it with the feeler gauge, and it wound up being about 30 thousandths of an inch. So that means there's a slight preload on that valve. Does that hurt anything? Well, I don't think so, because when I pull it out, just like when the solenoid is released, then I take some needle nose pliers and push out on the valve. I look down in there. You won't really be able to see it in the video very well, but there is a pretty good gap between that back land and where the relief cut was made in the valve body. So therefore, there's plenty of area for the fluid to escape when you release the brake. But it seems to me that if that valve came out a little further, you would have even a larger area and the brake would release even quicker. So I thought, well, let's take the solenoid off. Let's install the modulator gasket that normally comes in the kit anyway. Put that on the solenoid and thread it back in the case again. Now I'll take a look, and there's much less gap. In fact, I measured it. It was about 10 or 15 thousandths preload on it. So now when you pull the solenoid back and get the valve out of the valve body, and you look in there and you see there's a little bit more gap than it was before. I've got to think that that's going to release the brake a little bit quicker, you know, maybe only 1 or 2 thousandths of a second. But it seems to me that putting that gasket in it really kind of optimizes that valve position. I understand that there are some builders that like to have even some end play. So when the solenoid is fully in, you have 2, 3, 4 thousandths end play on the valve. So when it's released, the valve comes out even further. I believe in this case, putting the gasket on there and having, say, 10 thousandths preload on it, that should work just fine. Okay, before we leave, I want to give a special thanks to Carl Munroe of TSR Racing. He was good enough to send me a few of his products to show in this second edition. He also gave me some pointers and some inside information that really helped with this edition. So let's go around to the back of the transmission and let me show you those products. Okay, remember when we were talking about setting the case up for a double dump, you have this extra cavity that has to fill up with fluid, which could cause a slight delay of the brake engagement. So Carl sent me this item here. It's called a quick set. It's actually a lead plug that goes up in the cavity and displaces that area so fluid doesn't have to fill it. Now the plugs come a little bit large, so you'll have to take a pocket knife, or actually I used a wood rasp to hone it down so it would fit nice in there and flush with the back of the case. Now also remember, when you're running a transbrake, you need to have this plate to go on the back. And what that does, of course, is cover up the holes that you made to accommodate a transbrake valve body. And then you just simply take your stock governor support and put it on there and bolt it down. Now in this application, you would not use any gaskets. However, Carl sent me one of his nice billet pieces. It's got a roller bearing on the inside. It's nice and thick. It's flat on the back, so therefore you do not use that extra plate. You only use this. And on this application, you would want to use a gasket. Put it on, bolt it down, 15 foot-pounds, and you have a nice addition to a performance application like we're building right here. The next item is a high flow filter. I actually think this is a filter from a Chrysler product, and what it consists of is a little standoff piece that goes on the valve body here. There's a little gasket that goes under it, and you have a couple set screws that hold it in place. You have another gasket here, and then you put the filter on top. It really does a good job. You have more volume because these pumps are putting out a tremendous amount of pressure and volume, and you don't want a restriction in this area. One thing that Carl wanted me to point out is you can see that there's only a single hole here, whereas a lot of these standoffs for a deep sump pan actually have the 2 holes here and here. And he tells me he gets a lot of calls, people asking about, well, what happens when you got this hole that's open here? Well, understand that hole is for a rear pump model, and of course in a racing application you're not using the rear pump, and it's actually blocked off on the inside, so there's no leakage there. You only use the 1 hole. All right, the last item is this windage tray. It's actually a new product for Carl, and what it does, it sets down in the back of the oil pan. So let's see what that looks like. Okay, you can see what it does here. It's in the back of the pan. The filter actually fits down inside, so when you accelerate hard and the fluid tends to run to the back of the pan, this tray holds fluid near that filter. Also, it reduces the possibility of fluid splashing up into the rotating mass of the inside of the transmission. That would reduce foaming, and most likely it even helps with a little bit of horsepower, keeping that windage or that fluid away from the output shaft. I need to glue it in place. I'll have to mix up some epoxy, and I'll have to put a little bead in each corner to permanently mount it to the bottom of the oil pan. We'll definitely use it. Okay, this concludes the bonus addition to building a drag race prepared Powerglide transmission. I hope it gave you some insight and took some of the mystery out of the inner workings of this gearbox. Anytime you're in the shop, I want you to remember, be safe, wear your safety glasses. Thanks again, and I hope to see you at the drag strip.